Hi everyone, today we're going to be looking at some density practice problems. When we're thinking about density is going to be one of our types of properties of matter we look at, whether it be intensive or extensive. We're going to talk about what type of property density is tomorrow in class. We're going to play a game with that. But today we just want to be able to calculate density, to get it based on the information we can easily get in the lab. This is actually what our lab for us it'll be Thursday, is going to be about. So calculating density, the equation's up here in the upper left corner. That symbol kind of looks like a P, stands for density. And density is mass divided by volume. You'll notice your units are also there. Density always has the units grams per milliliters because we're always dividing something in grams by something in milliliters volume. Sometimes this would be like centimeters cubed. So looking at number one, we've got to be able to set up those numbers in that equation to get our density value. Number one says, a block of aluminum has a mass of 40.5 grams and a volume of 15.0 milliliters. What is the density of aluminum? To do this, we set up our equation. Density equals mass divided by volume. So we're going to have our mass, 40.5 grams. Grams always represents some kind of mass. And then milliliters, we got 15 milliliters. Milliliters is volume, how much space something takes up. Then when we calculate this, we'll put it in the calculator exactly like that. You can either use the N over D button, or you can divide it. You'll get the right answer either way. 40.5 divided by 15.0. And I got 2.7. Now the units here have to be grams per milliliter because we cannot cancel those units out. They don't match. So grams per milliliter. The density of aluminum is 2.7 grams per milliliter. Let's do one that's a little bit trickier. Number 4. Number 4 says, a marble has a mass of 3.50 grams. If the marble is placed into a graduated cylinder full of 25 milliliters of water, and the water rises to 26.1 milliliters, what is the density of the marble? So set up our equation. We know the mass right off the bat. Mass is 3.50 grams. But our density, we're given those two volume numbers. 25 milliliters was in the graduated cylinder, that was water. That water rose to 26.1 milliliters once we placed the marble in. So when you think about volume, it's the amount of space something takes up. And if something has an irregular shape or is hard to find the volume of, we can use this water displacement method, this is what this is called, to figure out the volume of the marble. So to get the volume of the marble, we'll take the final value that water rises to, 26.1 mils, minus the initial value that graduated cylinder had of water, 25 mils. And 26.1 minus 25 should be 1.1. So that will be the volume, the amount of space that marble takes up. I like to do that calculation before I plug in to that density equation and get my final answer. So now I'm taking 3.50 grams, the mass of the marble, divided by the volume that marble took up. And 3.50 divided by 1.1 is 3.18 repeating. So I'll just do 3.18 grams per milliliter. I'm not going to be too picky about how you round here, but don't forget those units. So I want you to try the other 4 density problems on this page. Remember, you might see another one that talks about water displacement in the future. So remember that displacement method, take the final volume minus the initial volume to get the volume of whatever irregularly shaped object we're working with. Make sure you include units, show your work on these, and good luck.